Hi all, my name is Simon Hutchinson. I'm a composer, a music technologist, and professor of music at the University of New Haven. I'm going to talk to you today about my work with artificial neurons and how I implement these in my sound synthesis. I'm excited about this work with artificial neurons for a few reasons, two of which are topics in audio that have excited me for a long time: feedback and audio nonlinearity. But the third, and perhaps most relevant for this setting, is the engagement with machine learning. Now, I don't need to go through the list of new programs and software that can generate music from text prompts. I was particularly blown away a couple years back by Google's Music LM. But in this practice with artificial neurons, I'm hoping to expressively explore this building block of AI, the artificial neuron, because really it's something so simple and really easy for anybody involved in audio to understand. In this work, I'm examining the aesthetics of the neuron's process rather than the output of the algorithm, making the neurons and AI the creative subject of this work. So, an artificial neuron is a mathematical function used as a model of biological neurons. And of course, artificial neurons are the elementary units of artificial neural networks. So, since it's a mathematical function, we can make an artificial neuron out of code or electronics. Now, when I get more specific on this, an artificial neuron is a mixer and a nonlinear transformation. One or more inputs comes into the artificial neuron, inputs are weighted, and the output of the mix goes through a nonlinear activation function. This activation function in machine learning is the function that determines the output of an artificial neuron based on its inputs. This function is generally nonlinear, and I'll get to why that is in just a moment, but in this case the nonlinear talks about the transformation of information that comes in. So a couple examples of this would be hyperbolic tangent function or rectified linear unit. Again, as an audio person, hyperbolic tangent is often used for soft clipping algorithms, and we call rectified linear units just half-wave rectification. And there are many other possible transformations. Okay, so why do we need that nonlinearity? Well, if every neuron in a network were linear, then the network could be simplified to a single neuron. And so by each individual neuron being nonlinear, it makes it impossible to simplify, and the behavior becomes more complex. Now, for listening to the output of this mixer with a nonlinear transformation, it's going to lead to different sonic possibilities. A neuron alone does not make for machine learning. These neurons and their networks would have to be trained and their weights adjusted for that. These artificial neurons on their own are just chaotic, non-linear mixers. Okay, so why neuron mixing? Well, directly, there's no real practical reason to do this. Clean, linear mixing is great. You know what you're getting. So let's talk impractical reasons then. As the late composer Alan Strange said, although the audio engineer and hi-fi buff do everything in their power to avoid nonlinearity, the composer may find it a useful tool. With AI permeating more and more of our lives, it's nice to have an artistic window into demystifying the technology, and repurposing technology for artistic expression is one of the most humane activities that we can engage in. Using art to show how simple these building blocks are and how they work together to create complex behavior makes machine learning less scary and more attainable. Through my compositional work with artificial neurons, creating my own 6 to 10 neuron musical brains has greatly improved my understanding of more complicated machine learning. And I believe this work can help artists imagine and develop more creative approaches to AI. Rather than focusing on how machine learning can replace my work as a composer, I'm engaging with the beauty of the chaotic behavior of these artificial organisms. And so, through using aspects of machine learning as an artistic subject, I hope to inspire audiences and other artists to take ownership of the direction of this emerging technology.